I'm going to consider again the y parameter model of a BJT because this is very easy to analyze when you compare the feedback component. So you see here, this is the input admittance YIE. This is the current source we have at the input side, current source we have at the output side. This is the output admittance, and I measure V out here, and I give V in here. And this feedback component YN is present between base and collector. This is a common emitter amplifier. You can see base is going to be the input, collector is going to be the output, and emitter is going to be grounded. So this is a common emitter circuit where I'm going to have a component YN which is connected between base and collector, and this is going to be the feedback component because feedback component are those components which are connected between input and output of any circuit. Okay, so by the definition of y parameter, if I want to find what is YRE, it is going to be IB by VCE when VB equal to 0. So YRE is going to be the reverse voltage gain, reverse admittance. The reverse admittance means you consider the input current and you consider the output voltage. So you know Y is equal to I by V. When you say YRE means reverse. Reverse means input side I'm going to consider one parameter from the input side. I'm going to consider one parameter from the output side. So input side I consider base current. Output side I consider the collector to emitter voltage. So it is IB by VCE when VB equal. So VB equal to 0 means input side I'm going to short circuit. So see here the input side is short circuited. So VB is 0. Input side is short circuited to find what is YRE. So if since the input side is short circuited, I can write what is the expression for the base current IB. So IB will be equal to this current YRE into VCE minus YN into VCE. So this voltage, you know, at the end of the YN is going to be one end of YN is connected to VCE, another end of YN is connected to ground because you know VB is shorted. So I can write this base current is splitting into two. It is getting splitting into this current and this current. So IB is equal to this YAE will go because anything parallel to short circuit, this YAE will also go. This will not have any impact. Okay. So this IB is essentially getting split into two components. One value is YRE into VCE, and another value is this one. Or I put minus sign because I assume that it is going to come like this. So the two currents are going to be coming and one current is going to be output. Okay. And you know, whenever you consider two-port network like this, all the currents are assumed to flow towards the network, right? So that is the reason why the current flow in YN is assumed to be from collector to base minus YN into VCE. You know, the current expression in terms of admittances, you know, V is equal to IR or I is equal to VY in terms of admittance. So the same way minus YN into VCE. So VCE is common, take it out. IB is equal to VCE into YRE minus YN, and IB by VCE equal to YRE minus YN, or IB by VCE is Y dash RE, which is going to be YRE minus YN. So if YN is not there, then Y dash RE will be equal to YRE. But since you are adding this YN between the input and output of your circuit, your Y dash RE is going to be YRE, the actual value of YRE minus YN. YN is going to be the feedback